Hello, ladies and gentlemen. Today we are going to have a nice picnic talking about submath concept for gaining submath knowledge. Today I'm going to take you to a little bit of a picnic to go over these concepts. I hope you are ready because today I was asking myself what time is it? Of course, it wasn't the time of the day, the time of the year. I said to myself, it's game time. And because of that, I'm going to ask you, are you ready? Because I'm ready. Bear with me and let's begin. So, today's topic is going to talk about a math concept that deals with modeling dropped objects. In this real-world problem, we are dealing with a sport experiment. Muhammad, in a sport experiment, must throw down a soccer ball from a height of 13.2 feet from the second floor. Find the time in seconds it took the ball to drop to the first floor.
One, two, three, go. Yalla.
Since the problem above is dealing with the initial height and finding time, we need to be thinking about the dropped objects model to solve the problem. And as we have here the model that is h equals negative 16t squared plus ho. Using the model, since the problem doesn't give us a final height, we know it's going to be 0 feet. So, as we set up the problem, it's going to be 0 equal negative 16t squared plus 13.2. Step number 1, subtract both sides. After subtracting both sides, divide each side by negative 16, as shown here. Also, later, take the square roots of each side, as shown here. Using the calculator to find the time, we found that it's 0.91 second it took the ball in the air before it touched down. And if we look at our timer, it gives us 0.91 second. So, this second real-world problem deals with the first one, which is similar to drawing model dropped objects. The only difference that this problem includes and deals with velocity, vertical velocity. So, let's begin. A college soccer player must throw the soccer ball onto the field. Since the official called the ball as an out of bounds, the soccer game ball leaves his hand 13.2 feet above ground at a vertical velocity of 18 feet per second. Now, we try to find how long does the soccer ball stay in the air before it hits the ground.
1, 2, 3. 1, 2, 3.
Well, as we see in the problem above, what's given? There is velocity given beside the initial height. I found the velocity by taking the time from the timer it took the ball to be in the air and once it hit the ground. And the timer gave me 1.63 seconds. So in the problem above, we are going to use the dropping objects with velocity model. As it's shown here, h equals negative 16t squared plus vt plus ho. We are going to plug in the 1.63 into t to find out how we get the velocity, which is in feet per second. Once we plug in and solve the problem to find t, we are going to plug the 1.63 from the timer because we are trying to find t to get our velocity. We plug in the 1.63 and as you see, we are trying to solve it step by step until we got to 29.3 equals 1.63t, and we got 18 after being rounded. So now, since velocity is found, we are going to write the problem in standard form. Number 1, 0 equals negative 16t squared plus 18t
plus 13.2. Now we need to use a quadratic formula since it's in quadratic form. And as we see, t equals negative 18 plus or minus 18 squared minus 4 times negative 16 times 13.2 over 2 times negative 16. So, as a continuation for the problem, we have came to the point where it's t equals negative 18 plus or minus square root 5121.6 over negative 32. Simplify. As we simplify, we found that time is negative 1.67. Now, since the time cannot be negative because the soccer ball was in the air for 1.67 seconds before it hits the ground.
Ladies and gentlemen, as a class and as a classmate, I do appreciate you watching, and I do hope that you enjoyed and learned some of today's key fundamental concepts that I have enjoyed talking about. I hope you enjoyed it. Thank you very much.